Assalamu alaikum. Welcome to Chemistry 9th lesson for week 2. That is from 13th April to 17th April 2020. We are going to continue in this week with chapter number 3. We have already covered first half of this chapter in previous lesson as a part of week 1. And now we will continue with the remaining topics as a part of week 2 lesson. Hope you people have completed your worksheet for week 1, and you might have graded it as well as the key has also been uploaded for that. Okay, let's get back to now our work for this week. Here I have designed an outline for you people to tell you what is coming up in this lesson. The total subtopics we are going to cover in this week are 5, and the written assignments associated are 3, along with 1 weekend task and along with 1 worksheet. Okay, I have distributed the tasks for you people to follow on daily basis, and associated assigned tasks have also been listed over here, and additional resources you may find over here, you can see. So you may find a separate file for these additional resources as well, so that you can open up them for the respective subtopic, and you can access and extend your knowledge accordingly. Okay, and assigned tasks are there for your practice. Let's move to now objectives of this week. For this week, we have lesson objectives associated as we are going to define periodicity of properties. Then after this whole lesson, you should be able to relate the repetition of properties of elements with their position in the periodic table. Defining and explaining how shielding effect is influencing the periodic trends. Next, you should be able to define and relate trends of atomic radius. Then, after going through this lesson, you should be able to compare the ionization energies and electron affinities of different elements, predicting the relative shielding effects and atomic sizes of different elements, applying different trends of chemical properties across the periodic table. Last but not the least, to practice the problem solving skills, and that's why the written assignment has been specifically designed to help you with it. Okay, let's come to now the subtopics starting for this week. The very first is periodicity of properties. That involves, actually it is about the shielding effect. Before going to shielding effect, we should define periodicity of properties. The word periodicity actually is used when you want to emphasize on the repetition of a certain thing after regular intervals. This is called as periodicity. And if, of course, as we talked about the properties and the characteristics of periodic table in last lesson, I mentioned that the chemical properties of elements, they are repeated at regular intervals, and this is called as periodicity of properties, shielding effects. Okay, shielding effect is actually defined as the reduction in the force of attraction between the nucleus of an atom and its valence electrons. As we know that nucleus is positively charged and electrons are negatively charged, so an electrostatic force of attraction exists that holds these electrons around the nucleus. So this electrostatic force of attraction decreases because of the presence of inner shells. This is called as shielding effect. So these inner shells actually act as a shield that hinders the force of attraction of nucleus reaching towards the valence electrons. If you may recall it simply by recalling Bohr's atomic model, chapter number 2, class pre-9th, that electrons are distributed in shells around the nucleus. So if the number of shells are increasing one by one, it means the shielding effect is increasing, because each added shell is acting as a shield. Okay. Trends. By trends, we mean that how a particular property changes along the period and along the group, which pattern it follows. So in groups, shielding effect from top to bottom increases. Here is an illustration for you people that clearly shows you what's happening along the period and what's happening along the group. See, along the group first. With every next element, a shell is added. Let's move from hydrogen to lithium. Hydrogen was having one shell, lithium having two shells. From lithium to sodium, it is from two shells to three shells, and from sodium to potassium, it becomes four shells. So with every added shell, the shielding effect increases. Whereas if we see in periods, let's talk about in periods what's happening. No new shells are added. See, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. With throughout the period, there is no addition of any new shell. As a result, we conclude that the shielding effect remains constant along the period. The reason behind, I just mentioned that there is no addition of new shells. Let me explain this with the help of a simple example. Let's take two atoms. One is sodium atom, potassium atom. Both belongs to group 1A, but the periods are different. One is sodium. Sodium is top to potassium, and potassium occupies a lower position. So if we apply this same trend over here, it means then down from top to bottom, the shielding effect should be increasing. Yes, it is increasing. If we see the sodium atom is having the number of shells, and if we count the potassium atom, the number of shells potassium atom is having, of course, the shielding effect increases as we reach to potassium. So you may come across questions in your paper or in your exams that which of these two atoms, sodium, potassium, any two atoms can be given to you, that may be from across the period, that may be across the group. Which of them is having more shielding effect and why? So the very first point will be the answer, which. Here we have potassium. Then why? The answer to why is that you have to relate it that they both are belonging to the group. So you have to relate the trend of group, that down the group from top to bottom, the shielding effect increases. So it means potassium is having more shielding effect because potassium lies more towards the bottom as compared to sodium. This is how you're going to answer the reasoning questions of this. Okay, now we are moving towards the next subtopic, atomic size. Atomic size is defined as the size of an atom. It is the average distance between the nucleus of an atom and their outer shell. So it means if I draw an atom, a Bohr's model, this is the nucleus. So the average distance that is from the center of to the valence shell, this is called as atomic size. Let's talk about the trends of atomic size. Trend means how the atomic size varies across the period and across the group. So in groups, from top to bottom, atomic size increases. From top to bottom, atomic size increases. Whereas in periods, from left to right, atomic size decreases. Let's talk about the reasons behind it. The reasons for this trend is that as we move from top to bottom, new shells are added. And if new shells are added, you may build a concept, start building your concept in your mind that if new shells are added, it means the size is going to increase. Let's discuss it with the help of an example. This is once again the example of group 1A. Okay. From lithium to sodium, C. The shells are added. Yes. From sodium to potassium, C. If the shells are added, it means the atomic size is increasing as we are moving down the group. Whereas, let's talk about periods. We said that along the periods, the atomic size decreases. Let's see. The reason behind is that the nuclear charge is increasing, but no new shells are being added. So let's see the example of a period. Lithium, beryllium, it is second period. It is second period throughout. Lithium, beryllium, boron, carbon, nitrogen. Look, see, there is a decrease in the size. Their measurements are also given to you. But you can also see them, you can visualize them, that each of the atom is decreasing in size as you are moving towards the right side. This is because when we are moving from one to another, the size is decreasing because nuclear charge is actually increasing. And as a result, the nuclear charge pulls the shells around it, and the shells, the size of an atom constrict inward. The charges, the nucleus actually, when the nucleus gets heavy, it actually pulls electrons inside. So as a result, the size of an atom decreases. Okay. With this, atomic size ends. Now let's move to the next, ionization energy. Next subtopic, ionization energy. Ionization energy is defined as the energy which is required, the minimum amount of energy required to remove the outermost electron from an isolated gaseous atom. See, I have selected an illustration for you over here. The energy which is required, you have to apply energy to remove an electron from the atom. Why? Because nucleus is pulling electrons. So in order to apply some force, you have, in order to remove that electron, you have to apply some force against that nucleus in opposite direction. So if I want to get this electron removed, I have to apply this force, and this electron will be removed from it. The more an electron is far away from the nucleus, less force will be required. And the more close an electron is, or the more strongly an electron is pulled by the nucleus, you have to apply the more force to remove that. It means the force which you need to apply is directly proportional to the nuclear pull. If the nuclear pull on that electron is more, you have to apply more force. If the nuclear pull is less, you have to apply less force. And same we can relate it with the far away. If an electron is far away from the nucleus, you need just a small force to remove that. But if an electron is close, then you need to apply more force. Trends along the periodic table. Let's talk about the trends. from top to bottom, as we know that from top to bottom, if we are moving from top to bottom, see, the shells are added. Every time the shell is added, the size is getting large. The shells are added. So if the shells are added up, it means the valence electron is getting far away from the nucleus. If it is getting far away from the nucleus, you need just a small force to remove that. So very small ionization energies are there. It means from top to bottom, the ionization energy actually decreases. The reason is that greater the shielding effect is there, and if shielding effect is there, the nuclear pole decreases, and nuclear pole decreases, it means you can remove that electron easily. Let's have an example of lithium, sodium, potassium. The ionization energy is decreasing down the group. Lithium having only, you can see over here, I have lithium having only 520 value. For sodium, the ionization energy is 496, whereas for potassium it is 419, decreasing down the group. So it is decreasing down the group. With every next element, it is decreasing. This is because of increase in shielding effect. Let's talk about in periods. In periods, as we move from left to right, let's see from left to right. Here is an example. Left to right, the ionization energy increases. You can compare the values over here. 520, then it is 699, then it is 801 for boron. The ionization energies are increasing. It means as you are moving from left to right, it becomes difficult for an atom to lose electron. Here is the trend also given and as an example. So you may be asked to compare ionization energies of any two, for example, lithium and carbon. You can be asked a question, which one of them is having more ionization energy? So you are going to answer it. Which one of them is having more ionization energy? The very first point of my answer should be my answer. Carbon is going to have more ionization energy. Why? Because in periods, as we move from left to right, ionization energy increases. And among these two given, carbon is more right than lithium. Therefore, carbon is having more ionization energy as compared to lithium. Okay, you can pause it, you can replay it so that you can understand it and develop your understanding accordingly better. Okay, let's continue to next. Electron affinity. Electron affinity is defined as the amount of energy that is released. It is opposite to ionization energy. I will mark over here. Opposite to ionization energy. Here the amount of energy released when an electron is added up in the valence shell. And now this time it is going to result in the formation of a negative ion. So both ionization energy and electron affinity, they result in the formation of ions. Once again, the units are same. Affinity, actually, by affinity, I recommend you to learn it by pointing certain points or by marking certain identifications. Affinity means attraction. So here the electron is being added up. Here I have an illustration designed for you just to help you out that if an electron is, the electrons are revolving around it. If I want to add up an electron from outside, then the energy will be released from that atom. That energy will be equivalent to the force of attraction with which that nucleus will hold that electron. So that amount of energy will be released. This is electron affinity. Let's talk about its trends quickly. In groups, the electron affinity decreases. It decreases. The trend is same to ionization energy, but in concept it is opposite. From top to bottom, the ionization energy in group actually decreases. Let's have a look over here. With every next element in the same group, the ionization energy is decreasing. 328, it is actually the energy released, so that's why the values are in negative. These are some examples illustrated which are showing you that the ionization energy is decreasing down the group. Let's talk about in periods. In periods, as we move from left to right, the electron affinity generally increases. Let's take a look along the period. With every next element in the same period, the ionization energy is the electron affinity is actually uh, increasing. So pardon me if I have mistakenly used in this mistakenly used the word ionization energy. We are actually now discussing electron affinity, but the trends are same. Okay, so do not get confused. This once again, the same type of questions are asked. That, for example, they may give you any two elements. They may give you along the group or along the period. For example, which one of them, fluorine or bromine, having more electron affinity. So I hope you will now be able to solve this question and why. The question is which one of them is having more electron affinity and why. So you are going to answer it now yourself. Yes, you can practice it again and again, pause it, listen it, and practice it again and again. We are going to move to electron negativity. Electronegativity is actually related to electron affinity. It is attraction towards electron, but this time it is the attraction of shared pair of electrons, and it happens in bonded. It happens in compounds, bonded molecules. Electronegativity is there. Pauling was a scientist that actually helped or devised a way to measure the relative electronegativity of elements, and he said that fluorine is having the most electronegative element of the group, and the least are cesium and francium. This is important from MCQ's point of view. So please remember these. This is important from MCQ point of view. Okay, the trends along the periodic table, electronegativity decreases, the same trend. It decreases down the group, and see the examples: fluorine, chlorine, bromine. Electronegativity decreases down the group, whereas electronegativity increases from left to right. Here you can see. And here is an illustration that helps. The most electronegative elements are found on the left side of the periodic table over here. So this is the electronegative elements, and here we find electropositive elements that you will once again discuss about electropositivity in chapter 8 of 9th class. We'll talk about it later on. See the example of electronegativity that increases from left to right. Once again, you may be asked to compare any two elements. For example, nitrogen or oxygen, which one is having less, this time less electronegativity. They may give you to confuse less electronegativity. This time the answer is nitrogen is having less electronegativity, because when we move towards the right side, electronegativity increases. So nitrogen is more towards the left side. So less electronegative nitrogen is as compared to oxygen. Okay. Let's come to, with this we end our topics for week 2. Let's come to the quick key points quickly. Recap. We talked about 5 properties that are repeating or changing at regular intervals along the periodic table, and we discussed shielding effect. Over here you are given with the group trends, period trends, and over here you are given the group trends. See these two, these two, shielding effect and the atomic size, they are following the same type of trends, whereas these 3 are following the same type of trends. They have common trends and they have common trends. The first 2, they are actually a slight differences there across the period. It is remaining constant, whereas the other is decreasing, whereas all these 3 increasing along the period: ionization energy, electron affinity, and electronegativity. Okay, let's quickly reinforce that what is at the end. Now you are given written tasks that are given in outline and will also be available as separate file. Weekend tasks to be completed at the weekend, and please do it. It is a 40-minute task. Be limited to the time and do it. Worksheet number 2 is associated. You will be provided key later on. Please try to solve it independently. That there are some additional resources with respective each topic. Please follow them to extend your learning. And if there are any questions, you're more than welcome in feedback. And for now, it's all for week 2. Stay home, stay safe, and all the best. Good luck.